This conference will now be
Hey guys, this
recorded.
is Naveen here. Welcome back to Naveen Automation Labs. So, guys, with this video, little surprising for you guys that we will be starting data structure and algorithms. Okay, with this particular video. So, I thought of creating the series since long, but I could not manage it. But now, so this series will definitely help you to crack really good interviews, especially if you are a fresher, you are in college. For placement point of view, also definitely it will help you. And if you're going for interviews, especially with good, really good product companies or good startups, either you are a Java developer or any kind of developer, and if you're an automation engineer also, or you're applying for SDET, definitely this series and these videos will help you a lot. So I'll pick really good questions, really good implementations, because data structure algorithms, there are so many algorithms are there, so many data structures are there. It will take a lot of time. Okay, and it's really difficult to explain also with a good example, with the right example. So I'll try my best to explain you guys, and I hope you will like it. Okay, so today's topic we are going to talk about that stack implementation. You must be heard about. You must have already seen array list and linked list. Although array list and linked list and hash map, those things we will do it later. But very common terms like stack and queue. How will you implement the stack operations? Okay, like that. So there are three important things that we need to understand with respect to stack. You can implement a stack with array. Arrays are static in nature, and so you can implement one static array and one static stack you can implement with the help of normal array. If you really want dynamicity, you want to create a dynamic stack, in that case you can use linked list also. So in the next chapter, in the next video, I'll tell you how to implement a stack using linked list, or you can implement a stack with the queues also. Okay, but there's a very famous interview question that, okay, how will you implement a stack using array? Although a stack is already, stacks and queues are already available in Java, you can directly create the object of those, okay, those classes and start using it, and you will be getting all these default operations. But the interviewer will ask you that, okay, how exactly you will implement your own stack. That's very important, right? Similarly, how will you implement, let's say, your own linked list? How will you implement your own arrays? How will you implement your own array list? Like that. So interview question will be totally dependent on how your design, how exactly you're going to design, what are the different methods, and on the particular class you are writing it, what are the different features you are providing while implementing it. Okay, so without wasting our time, first of all, what do you mean by stack? Stack is very simple, guys. So this is, let's say I'm going to create a stack over here like this. So this will create a stack like this. Assume that, okay, we are having some data in this particular stack. So let's see, I want to enter some data. So in the stack is divided into some multiple parts like this. So moment, let's say I want to add one over here. Okay, I want to push one. So there are two important things you need to remember in, okay, in stack. One is push and another one is pop. So you can push means to enter the data and pop means to fetch the data. And how exactly it will work? So push will happen from top to down. So the moment, let's say I want to enter one in this particular stack. So where exactly it will go? It will go here, from here, and then it will come over here. So this is one will be stored over here. Then let's see, next time I want to push two. So two will be stored over here, then three, then four, then five, like, and then six over here like this. So the stack will implement the data, will store the data like this. And when you do a pop over here, right, when you want to fetch the data, fetch the data on the basis of LIFO operation, right? So LIFO, you have to remember. LIFO means last in, first out. What is the last element that you entered? Six. We entered six over here, right? So last in, first out. So whatever the last element that you have entered, the first element it will be fetched. So whenever you are performing any pop operation, that, okay, hey, give me the data from this particular stack. So you will be getting a top position over here, whatever the top over here. So this pointer is called what? This is called top. Remember this thing. Okay. And the operation it will perform LIFO. Q will perform FIFO, FIFO, first in, first out, right? Just like we have a normal queue. First, the first person will get the first advantage, right? So first come, first serve. But here, last in, first out. Whatever the last element that you have entered, so first out. Okay. So this is the stack the stack overall view, how exactly you can do that. Now, whenever you want to perform or you want to implement a stack, you need to Remember three important things. One is the push, so that we can do a push. Then another one is that pop. Pop means push the element to the top of the stack. The moment, let's see, I have written 1, after that I want to push 2, then 3. So you have to keep pushing the data in this particular data structure, in this particular stack over here. And the moment you push the data, automatically the size will be increased by 1. So size of the stack will be increased by 1. So the moment, let's see, the first time the data was 0, the size was 0. The moment I enter 1, the size will be 1, then 2, then 3, and so on, like that. So the moment I enter the data, the moment I push the data, size will be increased by 1. 2 means remove the element, pop the element, okay, from the top of the stack. Remember, you have to remove the element, you have to pop the element from top of the stack, and returns the whatever the data is available over here, and the size will be decreased by 1. Remember this thing whenever you're performing pop over here. Then we have to check that, okay, that is empty or not, my stack is empty or not. That also we have to check. And the fourth operation, you have to write that, okay, my stack is full or not. So let's say you have given the stack size around 6 or 7, and once the entire all these 6 values are stored, I want to check that, okay, it is full or not. If it is full, then I cannot proceed further. If it is not full, then okay, I can still keep entering the data in this particular stack. And then you have to check peek operation also. How exactly you will be doing a peek? Peek means return the top element from the stack without removing it. Okay, so remember this thing. When you do a pop, pop will remove the element from the top of the stack. Remember this thing. Okay, pop means remove the element, and the size will be decreased by 1. But peek means whatever the peek is available. So let's say you just have filled only these 3 data. Okay, only these 3 values. If you have filled, in that case, what will happen? In that case, 3 will be given. Okay, 3 will be given to you. So remember this thing. Okay, so let's implement it, how exactly you can do that. So okay, I don't know this paint. Okay, so these are the 4 operations, guys, you have to do that. Let me just write it, place it over here. Okay, so in the form of coding also, these are the 4 operations we'll be doing it. So remember, pop means give me the first data, the top data, and decrease the size by 1. And let's say you have filled only 3. In that case, peek means peek will be 3 in that case, if you have only 3 values are available in this particular stack. Okay, so let's do it. Right, so I'll be doing another thing is that this time I'm not using Eclipse, I'm using IntelliJ. So side by side you guys can practice on IntelliJ also, although it doesn't matter, you can use the same script or same code, you can use it in your Eclipse also. Okay, so this is my IntelliJ, and I have already set up a project over here. We just need to download IntelliJ community version and start using it. This is my project, and this is a Java project you just need to create. Go to SRC, right click on it, or you can do practice same thing in Eclipse also. And I'm going to create a Java class, and let's see, I'm going to create my Java class as a stack implement or implementation or a stack imp, whatever, okay, the name you want to give. So this is a class got created, and under this particular class, what I'm going to do that see, now you have to check. First I need to decide, because this is, I'm going to implement stack using array. So I have to decide, okay, what exactly the size you are going to take it. So let's see, I'll declare first a variable as size over here. Okay, what will be the size of the array? And then I'll declare one array also over here, that a normal typical static array, I'll be using integer type, and data I'll be maintaining with respect to integer only. Okay, and then I'll be using that one top variable also. I'll be using it to check that, okay, what exactly the value is available on top position. Then what I'm going to do that, okay, I'm going to create a constructor over here. So I'll be creating a constructor. Let's see, this is my constructor, and this particular constructor, what I'm going to do that, I'll be giving the size of this particular, okay, this particular stack, that what exactly the size you want. And then what I'm going to do that, size, this dot size is equal to iSimple right size over here. Okay, so I'll initialize this particular size with this keyword, and same thing, this dot array, I'll be initializing it whatever the size that you are giving. So we know that, okay, how to implement a static array, and then the same size I'll be giving over here like this. And then this dot top, initially I'm declaring with -1. Okay, initially the top is -1 over here, like that. Now this is the constructor that I have created. Now what I'm going to do that, first I'm going to create three important methods. One is, first of all, I'll check is empty. Okay, and then I'll check is full or not. So how will you check? So I'll be creating a simple method over here, public, and let's see, void, it is empty or not. So if I'll check that, okay, if your top, whatever, so I simply say that, okay, return your top is equal to what? -1, right, guys? Then you simply return it. It means if top is equal to -1, return what? A boolean. So it will return false. So instead of void, what should I write? I have to write boolean over here. Okay, so it means my stack is empty. If it is top equal to -1, it means the size is, there is no top is available, so size is what? It's empty, totally empty over here, right? Then I'll be checking that, okay, it's full or not. So I quickly check, okay, public void is my stack is full or not. So in that case, I'll simply say that, okay, whatever, I'll be writing that whatever size that you are getting is full or not. If size -1 is equal to what? Is equal to top, right? So let's say the size is 6 -1, okay, and then which is equal to top, it means I'm getting the first element, the top element. In that case, you return it. It means I'll assume that, okay, yes, in that case, my stack is already full. So if it is true like this, in that case, I'll be writing boolean once again over here. So isEmpty and isFull method will return boolean, true or false. Simple. It's very simple. There is no rocket science. Size -1, sign -1 is equal to top. It means let's say the size is 7. 7 -1 is equal to 6, right? So if it is equal to 6, it means this is the top position I'm getting it. It means it's already filled up. It's full. If top equal to -1, it means my stack is totally empty. Perfect. Okay. Now what I'm going to do that I'll be creating another element, another method, that is a peak method. I'll be creating it. So I want to check that, okay, peak means what exactly the value is available on peak, okay, on top. So I'll be creating that, okay, hey, public. First of all, I'll be getting integer, so I'll return type will be integer, and then I'll be creating a peak method over here. And over here, what I'm going to do that I'll put a condition over here that if, right, this dot, I'll be calling this particular method, if it is empty, and then I'll put a not over here. It means if it is not empty, then what do you want? If it is not empty, then you simply write return array of top position, right? Return what? Return array of top position, right? Whatever the top position is there, it means that's a peak. Simple. So let's see, on top position 6 is available, so 6 is a peak. Let's say we have only filled only these three values, so the top is 3. So if it is okay, array top, then it is empty. It is not empty, whatever the top position is available, you simply return it. Else, what do you want to do? Else, you simple, let's see, I want to print something that s out, that your stack, simple something like this, stack is empty. And then what I want, let's see, if the stack is empty, I want to return something. Let's see, this time I'm returning -1. So it will return a -1 also. So peak is also ready, right? Simple method. Now I have to create two important methods, that is push and then pop. So now let's create the first push method. That how will you push an element? How will you add the element in this particular stack? So I'll be creating, let's see, public void push the element, and I'll be writing a method over here, a variable over here, that which element you want to push. So let's see, I want to say that, okay, hey, which element? So give me an integer element, and this integer element I'll be pushing it. But before pushing, what I'm going to do, first I'm going to check it is full or not. If it is full, no need to push. So I simple write is full or not, right? If it is not full, so I'm making one not over here. If it is not full, then what do you want? If it is not full, first of all, that you increase the top value by 1. So top plus plus, right? Immediately you increase the value by top 1, because the moment, as I told you, the moment we push the value, let's say I'm entering first value, the 1 over here, right? Increase the value, increase the size by 1. So that's why increase top by 1, and then I'll simple write array of top over here. So initially top was, let's see, -1. So -1 plus 1, 0. So array of top will be 0 is equal to whatever the push element that you are writing, right? Simple. And then I'll print over here that system dot s out over here that whatever the pushed element, okay, pushed element is whatever the element that you are passing over here, right? Else element is already full, then you simple print, let's say it's already full. This guy is returning false. Okay, it's already full. So this guy will return true and this not will make it false. So it will not come inside the if part, it will come over here. So I simple say that okay, s out, you simple say that okay, s stack is full now. Something like this, right? So my push is ready, right? And after push is done, I'll be implementing my pop. So pop means get the value, pop the value. Okay, so push is ready. Now I'll be implementing pop. Pop means whatever top value is available, you get it and then decrease the size by 1. So what I'm going to do, I simple write, let's see, public. So I'll be getting something, what I'll be getting integer. So return type will be integer, and then pop, I'll be using it. And then I'll quickly check a condition over here that if, which condition I'll be using. I'll be checking over here that it is not empty, right? If it is empty, no need to pop. If it is filled, then only you have to pop it. So what I'm going to do, if it is, let's say, is empty, is not empty. Okay, the elements are already there, so it's not empty. So is empty, that we have already seen, that is empty is returning you this integer, that okay, whatever the is empty or not. So it will give you array of top, right? So if it is come over here, okay, is empty, true or false, it will tell you. So let's see, it is empty is false, and then it will make it, this not will make it true. So what I'm going to do, first of all, that I'll create that let's see, I'll create another variable over here. Let's see, return top is equal to top over here, right? So whatever the top is there, I'll store in a new variable over here like this, and then immediately what I'm going to do, I have to decrease the size also, top minus minus, and then what I'll do, I'll simple write s out system dot out dot println. I simple say that okay, what is the popped element is there. So I simple say popped element is plus what will be the pop element, whatever the array is going on, and I'll be using this particular return this guy. Okay, like this. And if it is not, then simple I'll put okay, print else over here, and inside else I simple say that okay, system dot out dot println s out, your stack is empty. It means there are no values are available, so no need to pop it. So stack is empty over here, and once the stack is empty, so we have to return integer. So I'll simple write return -1 over here, right? Return -1. So this is the thing that we have to write. Okay, so simple save it in a second. So if it is, then we are missing one return over here, so let me write, you have to return array of this same return top. Okay, because we are returning integer over here, right? So I simple, I'll explain it again. Pop first I'm checking guys that okay, is empty or not. So assume that okay, it's just not empty, all the values have been filled, fine. So this is not empty, right? So then it will come over here, then it will, whatever the top value is going on, give it to this guy. So whatever the top is there, okay, give it to this return top and decrease the top minus minus. So top is representing what? Top is representing this index, whatever the value is available over here. Okay, this index value is available over here, and then top minus minus, it means decrease the size by 1, and then whatever the popped element is available, right? Whatever the popped element is there, array of return pop. Let's see, the first time array was top element was 6, So array of 6 will be written, and this is what I want, right? Array of 6 or 5, whatever is there, this is what I want. So I should not write array of top, because top I have to decrease. Remember this thing. That's why I'm using an extra variable over here to do this, right? Now the question is, all these methods that we have implemented, what is the time complexity for all the methods? The time complexity of all the methods, anyone? Can anyone guess? The time complexity for all the operations is O of 1. Remember this thing. Okay, the time complexity, big O of 1, because you just need to perform only one single operation to, there is no for loop over here. One single operation to perform all these operations. Perfect. Now, what I'm going to do, I'm going to test this. So let's test it, and then we will have public static void main over here. So I simple write public static void main, and how to call all these methods. So I'm going to create the object of this particular class, stack implementation. Let's see, I'm simple writing stack imp is equal to a new stack implementation. But here the constructor we are calling, let's say I'm giving that, okay, around size is 10. Okay guys, the size is 10 we are giving. So you can see that, okay, stack implementation constructor will be called. Here we have to give the size I'm giving 10, 10 will be given to this, so size will be 10. Okay, now what I'm going to do after that, once the size is 10, I have to check pop. So let's say I'll just perform the pop operation. So dot pop, right now it's totally blank, right guys? There is no values available, and it will go to pop, it will check it's empty. It's empty, yes, it is empty. And okay, so let's see. Okay, so let's run it and let's see it's working or not. So right click on it and run this. Okay, it's clearly saying stack is empty. Can you see that? Perfect, because it will 10 will be given to this, and then pop we are calling, so it will come to pop method. It is checking that, okay, yes, it's empty, yes, it is empty. So this is true, but this not will make it false, so it will come inside the else and saying that, okay, stack is empty, and return -1. That's it. Okay, perfect. Okay, now I'll add, okay, I'll add one separator over here so that you can see the output properly. So I can simple write, let's see, something like this. Okay, so first pop operation we have seen that. Now what I'm going to do that, I'll keep pushing the data. So stack imp dot push, first element, let's say I'm entering 100. Okay guys, 100, and let's see couple of elements I'm going to enter. Let's see, 100, I'm writing 200, then I'm writing 300, then I'm writing 400. 4 values, let's see, I have entered over there, and then I'll write a separator once again. So 4 values has been entered. Now I'm going to pop. Okay guys, so how will you do a pop? So I simple write again stack implementation dot pop method I'll be calling. Okay, so let's run it and let's see what happens. See, stack is empty, we have pushed the element 100, 200, 300, and what is the last in first out? What is the last element that we have entered? 400. And that when we are doing the pop operation, we are getting 400. It means my logic is absolutely working fine. Okay, so pop means simple popped up, and then now I'll perform pop once again. Now let's see what exactly I'm getting. So let's run it again. See, I'm getting 400 and then 300. Why 300 I'm getting? Because guys, what is happening? 100, 200, 300, 400 I have entered over there. So it's like that. So I have created 4 elements like this. This is 100, then this is a 200, then this is a 300, then this is 400. So while performing the pop over here, 400 has been popped up and the decrease size is decrease 1. So now this initially the top was pointing over here. This is my top. It was pointing over here. But when I popped up, this size is decreased. 400 we have already captured. We have deleted this 400. Now this top is pointing to 300. So that's why the next time if you perform pop operation, again you want to pop it up, then we will be getting 300, right? So that's why we are getting 300. Now let's do that one more thing. One more time I'm using pop. So next time I'll be getting what? Next time I should be getting whatever the popped element is available. The last pop element is available, that is 200, right? So something like this I can do that, right? Now I want to check that some other method. Let's say isEmpty, isFull, that we have already seen. Peak method, what is the latest peak is available? So after entering these values, okay, so let's see, I want to print it over here that the peak. So I simply write stack implementation dot peak method, and peak method will return what? Peak method is giving you what? Integer. So I'll do one thing. I'll just simply write s out over here, directly print it over here. What is the peak is available? Okay, just print it like this. So let's run it again and let's see. So peak was 400. You can see that, right? Peak was 400, but peak does not delete the data. Remember, guys, peak will just give you whatever the top element is available. It will not delete the data. Remember, this is the most important thing in stack. But once you pop it, the data will be deleted. 400 will be deleted. It will give you 400 and delete it. Then again you pop it, again delete it, and it will give you 300. Next time 200, but it will be deleted like this. So peak, this is the difference between peak and pop. Okay, and isEmpty, you can check that is empty or not. So let's see, I'm simple writing s out stack implementation dot isEmpty. So if you run it, it's saying false. No, it's not empty. Same thing that I some simple print s out stack implementation is full. So I'll check is full is also false because it's not totally full because the size is 10, right? So is full also giving you false over here. And push pop I have already shown you. Peak also I haven't already shown you. So this is a simple implementation of stack, guys. You have to remember this. You have to practice it. It's a little confusing, but please remember all these 4 operations. Push, pop, isEmpty, is full, and peak. These 5 operations you have to implement at a time of interview. And this is a very, very famous interview question in first round, that how will you implement stack using array. In the next chapter, I'll tell you how will you implement a stack using linked list through dynamic arrays. Okay, so that's all for this particular video, guys. If you have any queries, you can write down the next in the comment section, and please share this video with your friends who are preparing for the interviews. Very, very important series I'm going to start now. Okay, thank you so much, guys. And it's common for all, either you are automation engineer, dev, QA, fresher, preparing for your placement in your college. It's common for all. Okay, guys, so thank you so much, and I'll see you in the next video. Bye bye.